Welcome to AP Podcast 15.6b. We're going to finish up this solubility stuff here, and I want to talk about relative solubilities. And all that means is that about how much will dissolve. And sometimes you will be asked to compare which one of these would be more soluble. And what you'll see is they'll give you some Ksp values, and we can just look at the Ksp value. And you guys know from an equilibrium standpoint, if we have this AGI, right? And we've got this equilibrium, and it's going to break up into Ag plus and iodide. All right, if that's going to happen, look at this to 1 times 10 to the, or 1.5 times 10 to the minus 16th. There's not a lot of driving force causing it to go that way, right? I mean, imagine, Ksp is going to equal Ag plus and I minus, right? That's not going to be much of a number, to cause this equilibrium to go that way. However, look at something like copper sulfate, only to the minus fifth. That means these concentrations have to be bigger, right? If we just think about this mathematically. And so therefore, we can compare the KSPs and figure out who's going to be more soluble. Now, there is one super important thing. It only works if you have the same number of ions, right? So for example, all three of these compounds are made up of 2 ions. If we had something like, I don't know, aluminum fluoride, right? We can't compare the Ksp of aluminum fluoride to these guys because this one breaks up into 4 ions. And so that is definitely a problem. So we can't really compare. However, of course, we can do the math and figure it out. But if you ever see a simple question like, well, which one of these would be more soluble, all you got to do is look at the Ksp values and you can tell. Okay? Well, let's move on to the common ion effect. Now, we've already experienced the common ion effect when we were doing our acids and bases. So now it's the same kind of thing. If we're going to dissolve some powder into some water, less of it will dissolve if there is a common ion. So if we look at this simple problem right here, it says calculate the solubility of calcium fluoride with a Ksp of 4.0 times 10 to the 11th, right? So I'm just going to write out what would happen. Calcium fluoride would break up into a calcium ion and 2 fluoride ions, right? Now, we've got this, we're going to dissolve this stuff, but look what we already have here. We already have 0.025 molar fluoride. Okay, so if we just think of from an equilibrium standpoint, think about this. If I add a component here, according to Le Chatelier, which way does that shift the equilibrium? It shifts it that way, right? So you would expect less would dissolve if there is a common ion. Now they want us to calculate the solubility. So let's just go ahead and do that. So Ksp equals 4.0 times 10 to the negative 11th, right? And that equals the concentration of calcium plus the concentration of fluoride, right? And it's squared, all right? However, if we think about in terms of x, we want to solve that. And this is really, if you think back to the ice chart, this is really 0.025 plus 2x, right? Again, don't forget that mole ratio thing. Okay? Now, much like what we were doing before, we look at how small this Ksp. So what's the driving force to cause this to dissolve? Very little. So how are we going to make our math easier? Well, of course, we're just going to make this go away, right? We're going to say that it's going to be so small that it's not going to be a problem. And we can check it with the 5% rule afterwards. So that makes the math pretty easy. So the Ksp equals 4.0 times 10 to the minus 11th, okay, times 0.025 x. And when I solve for x, I get a value of 6.4 times 10 to the minus 8. Oops, wait a minute. Are you screaming at the screen? Are you saying, yo, Richardson, you forgot something? I forgot to square that. right? Shouldn't I have squared this value? I'm sorry about that, guys. You know I have a tendency to do that sometimes. I should have squared that because right in here went 0.025. I should have squared that value. Okay, now work out your calculator. The math should work. All right, so then we get 6.4 times 10 to the minus 8 moles per liter. Okay, so with a common ion, you're going to get much less solubility than you would without that ion. Okay, on to the next thing. Let's talk about this stuff with a little bit of acids or bases, right? Let's add to our excitement. pH and solubility. Holy cow, when you didn't think it could get any more exciting, now we're going to add acids and bases to this solubility stuff, right? And I know you guys have been through all this equilibrium stuff and acid equilibrium, and you're about going crazy, but hey, it's okay. We're an AP Chem, we can handle it. So I've got OH, and it could be a common ion. All right, so you can imagine if you added a base to a hydroxide, that would cause it to be less soluble. So if I took something like, I don't know, let's imagine I had iron 3 hydroxide, right? Had something like that. Okay, if I was going to dump in some base into our beaker, that would cause the equilibrium to shift that way, right? But we also have to think about what happens when this breaks up. Look at this. We've got calcium oxalate. It's going to break up into calcium and oxalate, right? Now, oxalate is the anion of the weak acid, oxalic acid, okay? So what would happen if I dumped in some H? I've got, again, imagine my big beaker here, right? And I dumped in some hydrogen. Whoa, I'm sorry, hydrogen, HCl. I'm stumbling over my words. Sorry, guys. I dumped in some HCl. What's going to happen? Well, since this is the anion of a weak acid, it's going to go ahead and attach to that, right? And so what does that do to that? That causes this to go away, right? So now we're making some oxalic acid. So the amount of this is going to decrease. So think about that. According to Le Chatelier, if we decrease this side, that's going to cause more to dissolve, right? So there's a couple ways to look at it. What happens if you dump in an acid? What happens if you dump in a base? Lots of chemistry to go on, and you got to really think chemistry when you're looking at this stuff. Okay. So, and here's the reaction right here of what's going on. And so an acid or a base could definitely play a role. So let's just look at something that's relatively simple. Let's imagine a question like this. For which salt of each group will the solubility depend on the pH? All right. And this is where it's really nice if you happen to know your 7 strong acids, right? Because we look at the anions of these guys. Well, that's the anion of hydrochloric. That's the anion of hydrobromic. Those are both strong acids, right? And this is the anion of hydrofluoric acid, which you well know is a weak acid. So this is the one that's going to depend upon the pH. Okay? Because if we have, imagine this happening. Right? If we had HF, right? And I've got AGF floating around, and you guys know this. So we're getting some Ag and some F. Okay. Now if this F minus is floating around and I dump in some H, right? What's it going to do with the F? It's going to combine, causing this concentration to go down, and we'll get more dissolving. I hope that makes sense. I know my chicken scratch is a little weird today, but I hope that makes sense. So let's look at the other two. Well, here's the anion of a strong acid. Nothing's going to happen there. But look at this. There's some hydroxide. So if I had lead 2 hydroxide, if I added some H plus, it would react with the OH, causing more of this to dissolve, right? If I added some OH, it would be a common ion, causing less of it to dissolve. Okay? Look at these two. Which one? Hopefully you picked that one. That's the anion of a weak acid, nitrous acid. Here's the anion of nitric acid. Same thing with this one. There's the anion of a strong acid. Here's the anion of a weak acid. So your answer is there and there and there. All right, I hope that made sense. I know I kind of went a little fast, a little scatterbrained. Those of you that are in my class right now know that I'm going through a cold, but we'll go over this, and if there are any questions, I'll see you in class. We'll talk about it. See you later.